It is necessary to identify an area on the spindle that is not affected by the movement of the tool change arm. Next, loosen the spindle screw. The use of a torque wrench is essential to accurately measure the original tightening torque. Completely remove the loosened screws. Loosen the set screws of the indexing flange. Position the stop block on the pin of the angle head. Mount the head onto the spindle and lock it. Press the spring-loaded pin connected to the stop block to its maximum compression in order to simulate the working position. Then measure the distance between the stop block and the spindle, accurately determining the actual gap. Remove the head from the machine to begin manufacturing the spacer. Once the spacer has been produced, mount the stop block onto it using the 2 screws, ensuring that the connection is stable and correct. This component must be manufactured with the utmost dimensional precision. Proceed with the final installation. Apply the stop block together with the spacer onto the spindle. Use the torque wrench to tighten the screws to the same torque as the others in order to achieve maximum machining precision. Uniform tightening torque is essential to ensure accuracy. Run the M19 program on the machine, corresponding to the spindle orientation function used during tool change. This ensures correct spindle positioning. Next, adjust the head by loosening the small screws on the flange so that the angle head can rotate once mounted on the machine, allowing final alignment. Insert the head into the spindle, ensuring that the head pin engages correctly inside the stop block and verifying proper mating. Once inserted, definitively tighten the stop block and spacer to the machine spindle, firmly securing the assembly. Tighten the set screws under the taper to correctly fix the timing between the stop block and the spindle keys, and tighten the 2 flange screws according to the specified torque. The stop block is then finally tightened so that it perfectly conforms to the pin. Finally, it is essential to verify that the head is perfectly aligned. This final calibration ensures that the installation has been carried out correctly and guarantees precision, safety, and reliability of the entire system.